So we are live.
Cool. Hello, everyone. We'll have just some small chit chat right now, and we'll start in about 2 or 3 minutes with today's program.
Marek, where did you get your t-shirt? It's awesome.
It's from Barcelona, of course.
I thought it looked familiar.
Everyone, we'll have just some small chit chat right now, and we'll start in about 2 or 3 minutes. Okay, guys, I think that we are all ready and set. So we can start today's Cloud Native Prague Meetup. Hello out there in the world of online reality. Hope you are all healthy and safe, and you are keeping your minds positive. My name is Jarda Machaň, and I'm the Chief Custom Officer in Revolgy. And this one is my very first experience with moderating online meetup. I've done a number of regular ones in the real world out there with a beer, and I have some great experience. For example, in Tallinn, where all participants were just slippers, and they were keep distancing of minimum 2 meters a year before COVID steps in the game. Let me thank all the great guests we have today, and also you participants of this 13 and hopefully successful and lucky Cloud Native Meetup Prague. Thanks for coming, because without you, we will be in the same situation like theaters and clubs nowadays in the Czech Republic, who can perform, but without an audience. Sad one. I'd also like to thank Revolgy, our company, and the great team led by Terka Grill, who organizes this great meetup, and also Marek Bartík, who brought 2 of our great speakers tonight. And let's have a look at who are today's speakers. We have ONDŘEJ ŠERY from Pure Storage. He will kick off the meetup with a first talk. He'll be followed up by Anton Vorobiev from Cisco with a lightning talk. And Alex Jones from American Express will bring the third talk. Please ask your questions. We will look forward to them in the chat during the talks. We'd also appreciate it a lot if you can provide us with your feedback, because it's super important for us. It's the ultimate source of learnings, and possibly now the only way how to improve the meetup. We will definitely send the link with a feedback form after the meetup ends. Also, do not miss the opportunity to follow us at meetup.com and twitter.com/cloudnativeprg. I'd like to point out one thing. We are really happy to have you here tonight, that you come, although we can't meet in a real meetup tonight and have a beer as usually, or a Wiener Schnitzel, you know, stuff like that together. But therefore, we can all look forward even more to one of the next meetups, which will definitely, I hope, happen outside the online world and with a glass of a proper beer. Let me now introduce the first speaker. His name is ONDŘEJ ŠERY. Ondra works as a senior software engineer in Pure Storage. His talk will cover the Kubebuilder tool, which is designed for extending the Kubernetes APIs and building operators in Golang. It's based on custom resource definitions. This talk will go through the basics of using Kubebuilder from the initial setup to deploying a demo operator in a Kubernetes cluster. Terka, can you please bring Ondra to the stage?
Hi there. Let me share my screen. So I hope my slides are visible. I have no way of checking since you cannot really respond. Anyway, let me start with Kubebuilder. But before that, let me also spend at least 1 minute with overviewing the company I'm working for right now and where we're using this technology, which is why I decided to describe it here. We are Pure Storage. We were founded in 2009. We went public in 2015, so we're a publicly traded company, started in the US and on the West Coast. We crossed 1 billion in revenue in 2018 and are growing basically the whole lifespan of our company so far. One thing we are especially proud is we are a leader in the Gartner Magic Quadrant, and our Net Promoter Score, which is whether our customers would recommend us to other customers, is exceedingly high. It's like 82, which is really good. More importantly here, we started office in Prague in 2020. So basically at the beginning of the year, we have almost a year of the office now. We've been growing at a very rapid pace. We have over 100 seats taken at the moment. This is mostly engineering. So we do real engineering for the company. Mostly we're interested in all-flash storage, but it would not be correct to say we are a hardware company, even though we create our own hardware. We spend a lot of effort on doing software using tools like Kubernetes, Terraform. We do a lot of C++, we do Golang, Java. Most of our stuff runs in cloud, at least the data processing pipelines. And we are still hiring, and we will probably be hiring for some time to go. So if you are interested, check our web pages and see our career page. Now to the actual topic. I will talk about Kubernetes operators and Kubebuilder in particular. So I will start with describing why you would even consider something like a Kubernetes operator and what that is. Traditionally, operating an application in Kubernetes has been relatively simple in the sense that if you have a stateless application, you just describe, I don't know, how many replicas you want to have, which Docker image version, tag, and stuff like that. And Kubernetes itself is very good at just starting that number of pods, making sure they're up. If something crashes, it will ensure it gets up again. It can do rolling updates for you and stuff like that. So for stateless applications, the operating part is relatively okay. You don't need to care about which machines stuff runs on and things like that as a developer. For stateful applications, sadly, this is not necessarily the case. Like if you have a application with database and you need to do a database migration, usually you do something like switching into read-only mode, then backing up everything. Then you do the migration to the next version. You do the actually upgrade of the database engine if you need to, and then switch back to read-write mode, possibly with some portion of that, just to make sure that if you crash, you crash just a few requests, not everything. And this is relatively complicated to do in Kubernetes in the sense that usually a human person has to come and do the stuff. Kubernetes doesn't help you itself with these tasks too much. So that human person is usually called operator. And the idea of Kubernetes operators is about, could we somehow take this domain-specific knowledge about that stateful application and encode it into an automated operator? And that's the whole point. Like a way to have a tool that would contain this domain knowledge and could be reusable. For example, if you use a database, I don't know, MySQL, Mongo, you'd have an operator, and they are there at this point. You can use them, and they would know how to upgrade between versions, how to do the backups, how to do all those stuffs, all this stuff that otherwise people would have to learn, and that takes time and is error prone. Basically, that means you can create in Kubernetes something called custom resources, custom resource definitions that are objects from your domain. So they contain domain-specific description of the desired state you want to see. This is an example how that could look like for Prometheus. There is a Prometheus operator out there. You can download it, you can use it, you can run it. It knows how to spawn the servers, how to connect them with Alert Manager, all these things that people historically have been doing themselves, and every single person using that would have to learn that by themselves. They can now use the Prometheus operator and would just describe in, again, domain-specific terms that they want a Prometheus to be installed, how much memory, for example, it has, and also a way to describe the Prometheus rules. So you would have one resource in Kubernetes for every rule or group of rules. And that makes it especially appealing for multiple teams that would reuse the same Prometheus, because without this, you'd have to manage those configurations and have a way to push them. Now each team can own their own Kubernetes resources called Prometheus rules, and the operator would make sure those are meshed properly and encoded in Prometheus configuration. This is done by this famous Kubernetes control loop that normally works out of the box for standard entities, such as, for example, you have a replica set, and that's something that describes the intended desired state of the deployment, let's say. The fact that you want 3 replicas of certain pod. And now Kubernetes, what it does, it observes what's the intended state, like, for example, these 3 replicas you want to have running. Then it checks the difference between desired and the actual state. So it looks at the number of pods that are running. And if it observes there are just 2, it sees the difference. And the last step is to take an action to remove that difference, to actually make the actual state be more like the desired state. It doesn't have to be in a single go. It could be like, it's sort of eventually consistency, right? You can try once and do it again and again, change the state until it matches. But every time it takes some action to try to remove a bit of the difference. So in this example, it would start another pod to make sure there are actually 3 replicas running. And this is the same idea with Kubernetes operators. You'd have those domain-specific descriptions of what you want. For example, MySQL with 3 replicas, and this and that version. And you describe that you, for example, want a different version of the engine itself. And the operator would know how to actually do the upgrade safely, how to back up everything and migrate stuff. So it would do this Kubernetes control loop, observe the difference that you change the intended version that should be running. It would see the difference that the old version is still running. So it would make one of the actions to make it closer to what you need. So it would, for example, start with the backup and do those series of steps that would lead you eventually to running the desired version of that server. There are different tools that you can use if you want to create your own operator. There are also many already existing operators for most common databases and things that are hard to operate, basically. Otherwise, it doesn't make too much sense. But if you want to create your own, you would usually look at these tools, like either Kubebuilder. It's relatively low level, and it allows you the most flexibility of these tools, I would say. Everything is coded in Golang. Obviously, there are some YAML files describing things like how to deploy stuff and the custom resources themselves. But most of the logic would come in Golang, so you can basically do anything you want there. So it's very flexible. But you need to understand coding, so it's not for like a random person to just write that. It's relatively steep learning curve. This is what I will be demoing today. Then there is operator SDK, which allows you to write operators in either Helm, Ansible, or Golang. Recently, the Golang part is switched to using Kubebuilder, if I understand correctly. So basically, learning Kubebuilder sort of kills two birds with a single stone, because you can reuse it if you want to go the operator SDK way. And then there is Kudo and meta control that I don't have much experience with. I just know that they are more high level and try to provide more declarative way to create operators. It's much more limited this way. Usually you would describe your operator in a YAML file or in meta control or also JavaScript. So it's more for simpler operators where you don't need that much flexibility. Okay, let's go to Kubebuilder. So this is how you can actually implement your operator if you're interested. This, just to mention, this is also not just for managing things running on top of Kubernetes, but you can also use Kubernetes control plane itself and use this eventually consistency control loop it provides to solve other tasks. That's, for example, what we are doing at Pure Storage in the recent hybrid cloud project that I'm working on. So not necessarily about the deployment itself, but to hold the source of truth or the desired state of something in our case machines that we deploy stuff on. So what is Kubebuilder? Kubebuilder is basically a tool set that generates project skeleton of an operator, and it's also able to cover like evolution paths to create new parts of that API. It generates a Golang schema of and the API definitions for you. It generates the actual controller skeleton for you, the place where you just drop your business logic into. It generates lots of boilerplate code for registering your controller and stuff like that. It creates deployment YAML files that allow you to actually deploy the operator into Kubernetes. It creates testing skeletons that helps you with unit testing. It also provides a Docker file for wrapping and distributing your controller or operator. And it creates a make file to sort of bind everything together. It's relatively simple, don't be afraid. I personally don't enjoy make files too much, but this one is relatively straightforward, so it's okay to use in my perspective at least. And as I said, it supports sort of evolution. So if you need to extend stuff, create new versions or new resources, Kubebuilder is not just one-off that you generate and forget. You can add those again with Kubebuilder and that stuff, as we'll see. In our example, we'll be creating a coffee maker operator. So I created a very simple coffee maker application in Go and built an image of that. This application just tracks coffees that are asked to be created. So you ask the coffee maker to create a coffee, and it will track those throughout the brewing process. But this is not the main part of the tutorial. This is just something we want to use. And we want to describe the desired coffees using Coffee Maker Kubernetes operator. And that's what we will be using Kubebuilder for. I'm running basically K3S, which is like simplified version of Kubernetes that's nice to run locally. And I'll just apply this coffee maker example, meaning I'll create the pods and deployment and stuff like that for the coffee maker. So basically, if I look at what's running in this K3S cluster, the Kubernetes cluster, it would be Coffee Maker here running. So it's one pod. You can see that it's in state running. So already downloading the image and everything. And there's also a Coffee Maker service running at port 30033. So let me see what it's saying. And it's empty. There are no orders. This service also has a REST API that we will call from our Coffee Maker operator. So that's our goal. In order to do that, we need to start a new project. So basically, we'll start from scratch, create a Go module, and then use Kubebuilder to populate it with the basic files that are needed. So I'll go to this empty folder. And since I'm lazy, I'll just search in the history So this will create basically empty Golang project. There's really nothing in it. Then we will run the second command to tell Kubebuilder to sort of initialize this space. It will not create any CRDs yet, but it will sort of create all the skeletons for it. So again, I'll search a bit, find the right thing. And now we can see that it created quite a lot of files. I'll switch to Golang. And it created a Docker file for building everything. The make file that I mentioned, it's like 2 pages, not super complicated on the boundary, I would say. We'll have a look later. There are configuration files for starting like monitoring if we need that. Sort of all the things bound together. And it knows how to sort of build the manager itself, the pod that you would be running that would run your operator. But it doesn't have anything else, and it even tells us that we should continue by creating some API. It doesn't do anything, doesn't define any API yet. So let's go there and create a coffee custom resource. So basically, we'll create an API. It has to have a group. It has to have a version. It will be v1, and the kind is basically the name of CRD, the thing that happens to be in the YAML files. So we'll do that. So that's this one. It will ask us whether we want to create a resource and the controller. We do. That's our intention, to create the definitions and also the code that will actually manage that. Now, this part would create this API folder, and in it, we would see various structures. The coffee here is the part that actually defines the object itself, but it's split into two sections. One is specification, that's the desired state, and that's something that user should edit and tell us what the desired state of the coffee is. And then there's a status, which is our place to write the status of the operations on top of that. Like we're probably, we'll start with queuing the coffee, then it would be brewing, and then it would be done. So basically those are the things that we want to keep in the status so that the users can see what we as a controller, as the operator, think about the state of the coffee. So we will have to populate those spec and struct parts to have the fields that we want. Then there's also controller, which is the code for the controller. It's just a skeleton for the controller. And the main part of this is the reconcile function, which is called each time that we should do something about a change of the resource definition in Kubernetes. So Kubebuilder or Kubernetes would call us whenever there's a change and we need to act on it. So our logic would come eventually here. That's more or less it. There's some boilerplate that I'm not going to go through. And there's also an example of the resource definition itself that I might still show because we'll get to it later. So basically there's this sample folder. And here's an example how to create one of those CRDs. So we can basically edit these and then pass it to the Kubernetes cluster to create the resource. Now, what we want to do is we want to fill it with the resources, with the fields. We want to fill the resource with the fields that we actually need. In this case, we will have a type of coffee and whether it needs extra sugar, and we have a status. There are special types that we may need to use at some point, but not in this demo. So, for example, there is special type quantity for holding, so the user-friendly definition of sizes, for example, amount of memory, and there's special type recommended for holding times, but we won't use it at this point. So what we want to do is go back to the definition of the coffee here, and specifically the spec. And what we want is to actually have the type. You have to specify the JSON encoding, and we also want this extra sugar, and that would be bool. and will be called in JSON extra sugar. So this will be the specification, and then there's the status, and we'll just have, let's say, I'm a bit lazy, so I'll just copy this and rename stuff. But you get the point. So this is what we need to do. There's one more thing that we have to add here if we want to use the status, and we need to tell Kubebuilder that they actually track it. So something like that. Then we can also extend this example to contain the field that we just added. So it would be like type, and let's say we do espresso and extra sugar, let's say true. And let's also use generate name, something like this, so that it generates new name for each resource. So at this point, we basically have the description definition done. We don't have the controller, but we have the description. So we can regenerate everything. So basically make, we could just run make, it doesn't really matter. And then we want to install it in the Kubernetes cluster. So if I go again to our cluster and check the custom resource definitions that it has, just empty cluster, it would have stuff from Rancher Labs, but nothing from us. It doesn't know about the coffee. But if we call make install, the definition of the resource would be created. So we now see the coffee here. So we can use this resource because Kubernetes now understands it and understands the field that we created. It doesn't have any, and it doesn't know which fields are important, but it understands the resource. So we've done that. We've installed the definition so far, not the controller, no code basically. And in order to create the resource, I guess we can create one right now. So just to see that it can be created. There's some glitch. I'm not sure which one. And yeah, I cannot use apply. I need to use create so that the name is actually generated. Otherwise, it would we do not understand the generate name that I created here just to have each name unique. Now, if we get to the coffees, we now see that there's one coffee with this random name. So it is there. You can even see what the specification is, that there's type espresso and extra sugar. If we go back, we see just the name here. That's basically the same thing. If I run kubectl here, it just sort of refreshes and helps with the view. But it's the same thing we would see with kubectl, but we don't probably like seeing just the name and age. Like for our resource, different fields would be interesting. So we can basically use this to signal which fields should be displayed if we use kubectl to get the resources. Let me be too lazy and just copy it from here because I don't want to write everything right now. So basically this thing comes, I believe, here. Oh, I'm not sure, to be honest. Yeah, probably here. Yeah, right. So, and this is just the description. So if we just run make install again, we already have the updated columns. So we now see the type and extra sugar, whether it's true or false. Another thing we may want to do is some verification, so validation basically of the input right now. And for this, we can use stuff like this. Again, it's a special command that Kubebuilder understands. And when generating stuff, it will generate the appropriate validation or schema, let's say, for the types here, for the fields here. So it would only allow us to create stuff if it's espresso latte or Americano. So again, if I run make install and try to create something which is not espresso, it should complain, right? It can be just espresso latte or Americano. So that's definition, at least everything I wanted to describe about the definition. Now again, this should go through, right? We should have another coffee here. Yes, we do. Let me get back to the presentation. Now we'll have a look at the controller. I hope you'll have enough time to code it, but let's do at least something. So what we want to do in the controller, in the code itself, so far there hasn't been any code pushed to the cluster, just configuration of the resource, and nothing would react on it. What we want to do is, in this reconcile loop, whenever we are called that the resource has changed, we want to get the Kubernetes resource, the desired state basically. We want to use the REST API of the coffee maker to get the actual resource, if it even exists. If it doesn't, we want to create a new one. And we want to update the status field of the custom resource in Kubernetes to reflect the state of the coffee, whether it's brewing, queued, or done. And until we are done, we want to requeue this operation so that we check again about the status and keep it up to date. So I already showed the controller. It's here. And we want to write our logic here that does the steps that I just described. As I said, we want to get the Kubernetes resource first. So let's say we want Kubernetes coffee, and it would be basically this beverage type. And we want to have Kubernetes sort of create it fill it for us. So we can do is we can call get. For that, we need context, basically meaning like timeouts and stuff, things that make this call interruptible, even though we just use background, which is not the best thing for production, obviously. Then we need to pass the name of the resource, in this case, namespace named. That is a name of the resource and a Kubernetes namespace. And we want to say where this should be stored. And if there was some error, we want to fail as well. In this specific case, we can return something like we didn't find the resource, which is the likely error, and just ignore everything else. Then now we have the resource, the Kubernetes one, and we want to get the actual resource from the REST server. So we need to include a little package for that, which is part of that application that I've shown you previously. And that's basically the REST client for that application. And we want to create a new client. And we want to tell the IDE that we know about these dependencies, so it should install it for us and help us with the naming. So new client. And we'll cheat here a bit and just use the Kubernetes DNS for the service for the coffee maker. It runs in the default namespace and uses this port. So this should be enough to get a new client, new REST client for the coffee maker. This is part of that package or that example package. I'm not going to go into the details. And then we want to get the sort of REST interpretation of the coffee. And again, that is something that can fail. So again, it's a context with interruptible, and it's a name. So for that, we can use the unique name of the Kubernetes resource. So we will be creating coffees, named coffees, so that we can identify them later on. If there is an error, we basically want to stop, but also we want to have this requeued. It could be a temporary error, so we just tell Kubernetes, okay, we didn't succeed this time, but maybe you should retry. And it's up to you, Kubernetes or Kubebuilder, to decide when you want to schedule another reconciliation. Now we have the REST coffee, and if it doesn't exist, this would be nil. So if REST coffee is nil, so empty, basically, we want to create a new one. So basically the client that we have here, just call it to create a new one, and that would take the name, it would take the type, which is something which is in the specification, is the type. Only thing I need to do is cast it to this enumeration type that the example application uses, but it's basically the same thing. And we also need to pass the extract sugar flag. So this should create the coffee if it hasn't existed yet. Let me do it this way. And also returns the newly created one, so we just store it in the REST coffee. We should really check for the error again, so let me maybe just copy paste this piece of code. Normally we would do some reasonable logging to also tell for debugging purposes what is happening. Let's keep it this way for now. Hopefully this would go through. If not, we don't have much to debug with. The next part was we want to update the status, because now in REST coffee we have the current status of the coffee as the coffee maker sees that. And for that, basically store it in the status field of this status structure of this Kubernetes resource. Again, we will need to cast it, I guess, coffee status. That's actually wrong. So let's just try to take it, and maybe it will just go through. No, so we need to cast it to string because we use string. That's fine. It's simple. And we need to store it, because just storing it in this Go structure doesn't pass it to Kubernetes. So we need to tell Kubernetes to actually update the status. So what we do is update the status, pass the context, and the updated Kubernetes entity. And since we are a good citizen, we will again check the error. And since it already exists, I'll just reuse the variable there. Now the last thing is, we've updated the status, it's created the coffee if it wasn't existing. Now we are done unless the coffee is in the done state. If it's in queued state, we want to keep the status updated as long as it is not done. So we want to tell Kubernetes if it's not done, we need to be called again. So basically, what we do is we take the REST coffee in the status, and if it's not done, we also finish without errors. So basically this way, but we'll ask to retry in, let's say, I don't know, 10 seconds. So in this case, we are not telling Kubernetes retry whenever you want, because we are failing and you'd rather do exponential backoff or something, but we just ask it to retry in 10 seconds because that's sort of reasonable frequency to get the updates. Normally, you would have a WebSocket or something, get updates, and Kubebuilder can also set everything up for you to watch on a Golang channel and be updated by that. So you listen on the WebSocket and translate events there to the channel and ask, and Kubebuilder will, or Kubernetes would let you reconcile stuff when it gets events there. But since this is a short demo, I'll just do it this way. And if you're lucky, we should be able to build this now. So let's try. So it went through, and now I'll do one thing just so that I can build this quickly. And what I want to do, I want to use a bit newer Golang, and I don't want, this is a default Docker file that's created for us, but we don't want to download packages here because it would take ages and probably wouldn't allow me to speak because of the bandwidth. So we'll just vendor all the packages. For that, we'd rather use a newer Go, which has vendoring by default. So we just say it got updated a bit. We'll do go mod vendor. It should do all the dependencies. Now we should have the vendor package here. Okay. If you didn't get it, don't worry. This is just to make this work a bit more quickly. And now we want to make stuff and deploy it. So we've done the controller, we want to deploy it. So how to do that? We build a Docker image. You need to push it somewhere. I will push it to GitHub. And we want to deploy this to the Kubernetes cluster. And if you're lucky, it would start creating those two coffees. If you're not, we probably not have much time to debug, but I guess you got the point here. So let's try. So we'll do Docker build and Docker push to this GitHub container repository. It regenerates everything, formats everything, runs the tests, and then start creating the Docker image. If you didn't forget anything, it would build successfully and push it to GitHub. So this is building basically all the dependencies. So it does take a bit of time, but at least it doesn't download everything, hopefully. Cool, so the image is being pushed. It does take a bit, but again, almost there, almost there. Once it's pushed, we'll deploy it by this make deploy step. So this one, again, we have to tell it the repository and the image tag, which we will do momentarily. So basically the same command, more or less, just deploy. It does use the default Kubernetes cluster in kubeconfig. So we have it configured to access the K3s local running. Now we should start seeing stuff here. So we see in the default namespace the coffee maker, but if we switch to all namespaces, we already see that there is this demo controller manager, and that's our operator. And once it starts, ideally, if everything is okay, it would notice the two coffees we've created previously, and it will try to create them on the REST server. So it's again downloading the image from GitHub where I just pushed it, and afterwards it should start. So it's in the running state. You can see there's a role-based proxy, and there's the manager itself. That's the thing, the container we are actually interested in. Didn't say much yet, which a bit not what I expected, but let's see. So, no, nothing yet. Okay, we failed for some reason that I'm not sure what that should be, to be honest. I won't do too much debugging. If this didn't go through, I'll probably just give up. What we ideally would have seen would be this calling the REST service and coffees appearing there. This will retry, but I have little hopes it will succeed. So let's give it last chance. If it doesn't go through, there's something wrong. Possibly even with my K3s instance, because it did say it cannot speak to the Kubernetes API, which is sort of weird. So let's wait a bit. It's taking too much time. The same error. Yeah, that's weird. Sorry, guys. I don't know what else to do. Live demo, as always. That's all I had, actually. There are some resources that you can have a look at. There's a Kubebuilder on GitHub, obviously, but there's a relatively nice and detailed documentation, GitHub Builder IO. If you want to try Q3S, I recommend. Even though the demo now failed a bit, I like it for just testing stuff locally on Kubernetes. And I will upload all these materials to personal GitHub after the talk. So that's all from me. If there are any questions, I'll ask someone to read those for me.
Thank you, Andrea, for your great talk, and especially the hands-on demo, because I perceive this leading by example approach as the one of the most valuable one. And as Alex
I'd rather
Jones,
much lead with an example that succeeded, but yeah. That happens.
Yeah, as Alex says, demoing something as complex as an operator on live demo isn't easy. I completely agree. I have one question from Anton. How do you guys in Pure Storage manage the life cycle of your operators?
Probably depends per operator, I would say. In our case, I wouldn't say we have this totally solved yet. We are working on a project that hasn't been released yet, so that's not the part we focused too much on. But Kubebuilder itself supports versioning of the custom resource definitions. So whenever you want to upgrade the API itself, you just create a new version, and then you are sort of required to be able to translate between the different versions to be able for your operator to be able to seamlessly upgrade. So that's something Kubebuilder already helps you with.
Perfect, thank you. If we will need any additional detail or discussion, we can definitely have a discussion in the networking meetup after the meetup. And now, please, thank you once again, Ondra. It was great to have you. And let me introduce our second speaker. This is our friend Anton Vorobiev, the master with a crab above his hat. And Anton works as a CRE for Cisco. And Anton's talk will cover the NixOS, how and why Cisco Orbit team has chosen to run NixOS as a base operating system for all their virtual machines in AWS. So Turga, please bring Anton on the stage. The stage is yours, Anton. Welcome. So we are having some technical difficulties with Anton's connection at the very moment. So can we hear you, Anton? Can you hear us?
Yeah, I can hear you guys.
Perfect. We can hear you, and we have the image as well.
Yeah.
So
thanks for that.
The stage is yours.
Yeah.
Here we go, man.
Sorry for the difficulties. I will try to share my screen. Hopefully it will work. So Can you guys see my presentation?
See it, man.
Perfect. Let's start then. Hi, everyone. Thanks for joining. This will be a lightning talk, but I just realized that I forgot about one thing during my dry run. I forgot to measure the time, so I have no idea how long will it take. I'll try to keep it short. I assume that Cisco doesn't need an introduction, especially during the lightning talk, but a couple of words about me. Many years ago, I was a developer who later turned into a sysadmin, and today this term, like sysadmin, is met rarely, but I do administrate some systems from time to time. That's why I still call myself sysadmin. Cloud enthusiast, because I like to over-engineer stuff, and I always excited to think and reason about the high loads. Currently, I work at Cisco as a site reliability engineer on one of our cloud security products. Some of you may recall me from previous meetups as a dude who takes pictures from the stage before he starts talking, and I feel like I cannot disregard the tradition, so please let me take a selfie with you guys. Cool. Now, even though it is a cloud native meetup and it should be all around the containers, orchestration, all that fancy stuff we love, I will talk about the cloud, but in more traditional and boring way. I mean like VMs. Again, it's a lightning talk. It will be very hard to introduce new technology. I will just try to uncover the curtain and give you a further direction for like everyone who is interested. And I hope that there will be someone interested in this technology. So take it as an elevator pitch. I just liked the technology so much, I want to propagate it to the world. The goal of the whole presentation is to talk about how to achieve or how to achieve immutable infrastructure principles with as less pain as possible and how we do it in Orbital team. But first, let's just align on inputs and remind ourselves what the immutable infrastructure is, so that we are on the same line. Traditional mutable infrastructure is approach when operator or automation tool does system upgrades or system reconfiguration in place, system changes, let's say, in place. And that is what we have been doing for a long time when we were managing a ton of bare metal servers through the data centers. And this approach has a number of drawbacks we all know. If I can use a term, a database term, it is a partially committed transaction, which, yes, can be applied to this approach. Also, repeatability of deployments is not great. If deployment has been done cleanly in a staging environment, it does not necessarily mean that it will also be clean in production. The configuration management tools like Puppet, Chef, Ansible, they do lower the risk, but they do not eliminate it completely. And also, they do not help much with the rollbacks. Immutable approach solves all these issues I have mentioned, but it is not without trade-offs also. So what if your service relies on a data written on a local drive? How the change of the system can handle the situation? And smaller and more frequent changes require the same processes, like redeployment of the whole system. So this approach was rather hard to implement in traditional DCs, because you have to redeploy the whole operating system. But in cloud environment with dynamic provisioning, APIs for everything all over the place, it is much easier. But still, there is like a choice to be made on how to implement the immutability. Whether we want to build a new image and recreate the VM for each tiny change of the configuration of the service, or should we rather adopt, let's say, configuration management solution from, I don't want to use the word legacy, but from like traditional way into the cloud, and deal with potential infrastructure drift by auditing, monitoring, or auditing the state and so on, by introducing the supervision, let's say. So today I will talk about Nix components, which help us in Cisco Orbital to maintain our immutable infrastructure in AWS. And full disclosure, I have a short hands-on experience with NixOS, about like 6 months or so, but I use it on daily basis for this time. And Nix is something I've been reading about for a number of years. It is like I roughly knew how the thing works and always wanted to try it out, but it was one of those things on your to-do list you never have time to spend on. Until this year, I was thrown into the water at Cisco, and yeah, tried to figure out how the thing works, and I loved it. I really loved it, as much that I migrated my laptops, my like daily OS from Arch Linux to NixOS, and never regret it. So, Nix ecosystem has a number of projects and components. We will shortly walk through some of them. These things in bold, those are like core components we use in Orbital team. We also have some custom tooling built on top of Nix, which at some degree intersects in functionality with some of the upstream projects like Hydra or NixOps. So we are not using them. But yeah, other things are like really common. And on the slide, there's like technology stack of the Nix. We have Nix expression language, then packages, or I would rather say, yeah, okay. Packages are described with this language. And then there's like, let's say, a repository or a channel of upstream Nix packages, and a Linux distribution NixOS, which is built on top of those packages. And we will walk through these components rather quickly. So 5 minutes. I think I can be, yeah, I can be okay with like 10, 12 minutes. Cool. So Nix is purely functional, which means, yeah, pure function is a function in mathematical sense. Same inputs always produce the same output. So atomic upgrades and rollbacks are backed by symlink mechanism. We will take a look at this. And each NixOS environment or component, it encapsulates all the dependencies, which sounds terrible, I know, but again, we will take a look at it later. And this feature has really cool advantages. You don't have to solve dependency hell when you want to install two services which have the same, let's say, library as a dependency, but they require different versions of this library, or they require some like conflicting, let's say, libraries which cannot coexist. Yeah, so when you install, oh sorry, I forgot another crucial feature of the Nix package manager is it is multi-platform. It supports Linux, FreeBSD, and OS X, so you can install Nix. You don't have to install like NixOS, as we've seen in our stack. You can use only Nix package manager for managing the software in any Linux distro or in your OS X. And how it's done. I hope that you can see my mouse. Yes, you can see. So all the derivations and closures, which we'll be talking later, are stored in Nix store, and default path for the Nix store is /nix/store, which can be overridden, changed. Derivation is a primitive into which Nix expressions are being translated to, and closures, you can think of a closure as a complete deployment with no missing dependencies. So as I've mentioned on previous slide, Nix is multi-user out of the box. So when we have in our operating system, when we have several users, they have the Nix profile, which again is being propagated via the environment variables to a shell. So your path variable doesn't point into user bin at first place, but at your home.nix profile / like bin and so on. So let's just take a look. Let's say I'm not Alice, not Carol, I'm Bob. I have my Nix profile, which points to default profile. Blue arrow means symlink. By the way, this image is from NixOS, or not NixOS, Nix manual. And my default profile points to closure, like my environment, and my environment uses SVN of version 112. And another user environment, or like default for 3, points to another closure, which again points to or has like symlinks to installed packages like Firefox 101 and SVN of another version. And basically what happens when I install those two packages, SVN and Firefox, they're being extracted into the storage. Then my environment is being changed, and symlink of my profile again is being changed from the previous profile to a new one. Nothing is being erased, yes, so the older SVN 112 will still exist, but we are just playing with the symlinks. And these weird names, these are IDs of the package, let's say. So we see name, version, and a hash of the content. So even if you have, let's say, 2 applications with the same version number, but for whatever reason they have different content, they will be treated as 2 separate like installations. Yeah, I've spent too much time on this, but I hope that this is clear. Yeah, so the thing we have to understand that there is like some Nix store, we have some binaries which are identified by this weird stuff, And by playing with the symlinks, we can build up a system without any external dependencies, and then link them to your path. Cool. Very quick about the Nix expression languages. Nix expressions language. So it is like domain-specific language for describing derivations, which are building blocks of the Nix package manager. And again, it's purely functional, declarative, and lazy, which means that expression is not being evaluated until it's really needed, until it's not referenced from any place. And there are some examples I wanted to show you. Yes, I think that the font will be small. Hopefully, you will see. But I will just point out the important moments here. So we are looking into a Nix expression which declaratively defines TANF, which is monitoring infrastructure, let's say, product written in Golang. And I will just point out, yeah, so this is the whole expression. When it's evaluated, it returns a derivation that can be used in a system closure. Yeah. The main function we call, and the only function is build go module, which we include from the standard library. And this function has some optional and required arguments. So we have like package name TANF, we have version, and as a source, we use composition of another function fetch from GitHub. So I wanted to show how we can construct the expression with the help of very rich language, standard language library. So what it does, it fetches sort from GitHub with this like revision, this project, blah, blah, share hash, cool. Then we have src, which is being transferred or given into as an argument to build go module. Again, vendors hashes, like vendoring hash is being checked. If something is failing, then Nix build process will tell you that. So we override some versioning, some metadata. We are good to go. So this is how Nix package is being defined. Another example is pgtop, which is like top command for Postgres. It's written in C, and it's built with another function, which is like standard library make derivation. Again, source is not fetched from the GitHub, but we have like fetch URL, so we download the source. In this case, we can define build inputs. This is how the dependency graph is being built. And again, we're just using default builder here, so we are not even overriding it. So these are two examples which hopefully will give you information about how the Nix packages are being built. So Nix also has a collection of installable packages described with the expression language we've seen now. And this is a screenshot from Revolgy.org. Do not mix with the Revolgy, it's like Revolgy. Horizontal axis shows number of packages and vertical axis number of fresh packages. So here we see all the Linux repository distributions we know, different Ubuntu's, Fedoras, Debians, such. Here is like the Arch Linux, and in this circle there is like Nix packages stable channel and unstable channel. So they are really rich what regarding the number of packages and freshness of the packages. For instance, in Orbital team, we use a lot of upstream packages like HashStack, ELK components, NUTS, NUTS streaming. These are always reasonably fresh, and there is no need to support custom packages which have to be newer than upstream. This is what we would be doing if we were running on top of Debian, for instance, and such. And by the way, NixOS releases are being cut twice a year. So the latest is 20.09, which came out in October, if it makes sense. Yes, and now finally a couple of words about the NixOS itself. Obviously, it's based on Nix packages. And the whole system is defined in a single declarative configuration file. If you want to make a change into your operating system, add or remove package, change component configuration of any component, whatever, you change this config and rebuild the system. And a single configuration for the whole OS sounds scary and inconvenient, but there's config of my laptop. It is about like 200 lines of formatted code with commands and spaces, and all the client software included. Also, there's mechanism of overlays, which is out of scope today. Another killer feature for me, not related to cloud, is when you change NixOS config and rebuild it, previous system closure is saved, as we've seen in our slide with the paths. And the previous system closure is saved as an old generation and is available through the bootloader, whether you use grub or systemd boot like I do. There's a photo of my laptop I've done today in the morning. So I have a horror story of upgrading laptop in the airport from my past. I've been using Arch Linux those days, and it went terrible. I bricked my laptop, and I had a nice quest of resurrecting it in a foreign country. Would never happen with NixOS. And also, if we are talking about the closures, they can be treated. There is some analogy with the Docker containers. Yes, with the Docker, we have some layers which can be shared through different images. And here we have some packages which can be shared through our different closures and system closures. And finally, this slide is basically my presentation. So how on earth in Orbital team we use all the stuff I've described in the cloud? So this is how our system closure delivery pipeline looks in AWS. We change Nix expressions in our Git repo. After the Git flow process kicks in, it is completed, PR is reviewed and merged. It's been built and copied into S3, which is supported by Nix out of the box. So Nix supports S3 as one of the backends for storing the closures. And then when we want to activate our immutable VM, again, the copy process is being initiated from the VM itself, and switch to configuration command is being called. This is how we deliver a a closure which encapsulates all the dependencies we need into VM. The difference between this approach and configuration management is that we swap the whole system with a snap of our fingers. Yes, we are not like evaluating whether we need to upgrade like this service, whether we need to inject these lines into this configuration and reload like these dependencies. No, we have like complete system which we are swapping. The difference between having this approach and golden image is that we are not building the VM. Yes, the VM is the same. We are not, oftentimes we are not restarting the VM. Yes, because Nix copy from means that we are copying the closures, but there is like, again, as with the Dockers, as we were pulling the layers, but some of the layers were already in place. So this is the same approach. We are copying the closure, but if some of the packages are here, we are only copying the difference. Then we have a new graph of dependencies, we have a new system closure, and we switch to it. So that is why we chosen it. It is like best of both worlds, I would say. And yeah, let's keep in touch if you want to. There's my Twitter, my Instagram with 2 posts currently. I promise to fill it with some technical content. Also, I have a TikTok account. I warn you, it can be too bizarre to open, but for the brave ones, this stuff is more important. These are some like links for further steps for any one of you who would like to know more. I highly recommend Nix Pills and Learn X in Y minutes, where X is Nix, and all the standard documentation, which is really high quality. This course also there. If we have any questions, thanks for your attention. Yarda, the word is yours.
Thank you, Anton. Thank you for the great talk. By the way, the name Nix reminds me of one of the very first social network in Czech Republic, but this is long ago, before Facebook hit the ground. We have one question, actually. GVolp87 asks, is there any open source project from Cisco that uses Nix? And also, if you can then provide a link for the slides here.
Yeah, I thought that there will be this question. Now, we haven't open sourced our like system, let's say, or like a system of tools built on top of Nix. And the reason is that it is highly coupled with other custom tools. Our repository structure is like monorepo, and it just doesn't make sense to open source. No one will benefit from it. So yeah, but I've mentioned open source projects like Hydra, DisNix, and NixOps. Those are open source tools combined, giving almost the same functionality we have internally. So I highly recommend taking a look at this.
Perfect. Thank you for your answer. Once more, thank you for the great talk. And now, let me introduce our third speaker. His name is Alex Jones, and Alex works as an engineering director in American Express. And he's also a former employee in companies like Microsoft, Sky UK, or Beam. I'd like to thank you a lot, Alex, for accepting our invitation.
Thank you.
Alex will speak. Perfect. Alex will speak about the Open Policy Agent. In other words, your passport for enterprise interoperability. And Alex will discuss how Open Policy Agent can be utilized to create a common vocabulary between teams and start to help them work towards a common reusable architecture that enables delivery and creates trust. Alex, the stage is yours. Thank you, man.
Thank you. I also apologize for the wordy introduction there. That really is quite a lot that could be cut down. So thank you, first and foremost, thank you for having me. It's a real honor to be able to be here with such a great community. Tonight, as was said, I'm going to talk to you about Open Policy Agent, which is a Cloud Native Computing Foundation incubating project, and how it's making waves within enterprise organizations. As we've got a variety of people on this call, some more than technical than others, I'm going to spend a little bit of time explaining some of the more nuanced concepts, some of the things that are a bit more technical, but please feel free to ask any questions and I'll do my best to answer them. I don't have all the answers, but I'm hoping that this will entice you enough to look at OPA, or OPA as it's called. Just lastly, I will try to make up for some of the time, and I think that I can probably do this in about 30 minutes so that we can all have a beer afterwards. So without further ado, let's get started. So I am Alex Jones. I live in London, United Kingdom, as per my accent. And I just wanted to give you some context on who I am and what I do day to day and why should I be talking to you about OPA and Cloud Native anyway. So my work is an intersection of DevOps practices, such as site reliability engineering, on-call optimization, distributed tracing, observability, writing Golang microservices, gRPC, Linkerd, service mesh, all those kind of fun, exciting things. But really, for me, the thing that I'm interested in is the institutional challenges, right? So when you work at a company, there are all sorts of problems that aren't technology. Technology is the easy bit. And really, that's why I got interested in becoming a Continuous Delivery Foundation ambassador. The Continuous Delivery Foundation is part of the Linux Foundation, and the CDF is really interesting. It's quite a new organization, and it's a collective of members from people like Tecton, Spinnaker, Jenkins, all these great CI/CD organizations who want to improve and make the delivery process of modern software a bit better. And this aligns quite well with my ambassadorship to the DevOps Institute, which is an organization that focuses on people behind DevOps, right? Who are the human beings that are driving these practice changes? And, when this contractor comes in who's a DevOps engineer, what are they really doing? How are they thinking? What is the thing they're trying to achieve? Is it just Agile 2.0? So this organization is great to dispel some of those misnomers. And it's also why in this talk, I will add a slant of the human aspect and the culture aspect on things that we can solve with technology, like OPA. So first and foremost, the story always starts somewhere. And this story starts with developer experience. Developer experience is really important because it's a barometer of how sophisticated your organization is, right? And as such, when I was asked to help improve DX of an organization, it became very apparent soon on that the developer experience often has a ratio, right, that's directly impacted by the underlying infrastructure interoperability. And that ratio and that interoperability, I'm going to explain what I mean. And before we do that, let's just talk about what does the word interoperability mean? It's hard to say, even as a native English speaker. In this context, interoperability is how well do all the bits fit together, right, of a distributed system, whether that is Cassandra running on-prem, S3 in the cloud, and a bunch of microservices to a mainframe, right? Interoperability is how well do those things fit together. And some of that also might include how well does this all work when I add Jira into the mix, when I add PagerDuty into the mix. A lot of these tools were never designed to work together. And that's why when we think about, as I said, with SRE and DevOps, this idea of measuring through qualitative data, how do we measure interoperability? What are the scalars? Well, the scalar is joy and pain, right? And I'm not trying to be facetious, but really, if it's painful to work at a company, then probably the interoperability sucks. And so if you think about that last time you're on Slack and you just thought, hey, this thing sucks so much, I have to wait 3 days for an approval, or this automated thing breaks tests that aren't even related to my Docker image, that is an indicator that your system's interoperability is very low. And it's a term that we use when we're thinking of how do we quantify the journey product engineering teams faced when they're releasing software and where those interconnected systems are and how they facilitate that. So a good place to start is what does good look like? And this graph here hopefully looks familiar to you if you work at a small company. Usually when you start at a small organization, you've got the luxury of firstly getting your own Mac or Windows machine, installing your own tools, and then the journey is one of like acclimating, learning how to use the Git process. Maybe they are crazy and use Git flow, and then using the CI/CD. Maybe you even deploy to K8s, right? If it's a small enough company, maybe you just do kube control apply, right? What's fun about small organizations is that when you see a problem in the DX, usually somebody fixes it. So if there is an onboarding document where it says brew install this, but you're trying to install OpenJDK over Sun JDK, someone will say, oh yeah, just change that, and then you're up and running. And often in your first week, somebody has ironed out the kinks and you're all up and running. Now, having worked at a few enterprise organizations and built this from experience, this is kind of how it looks like in an enterprise organization. And note the x-axis there. To contrast the really simple experience in a startup, the graph for an enterprise organization should probably have at the top, abandon all hope, ye who enter, when you're joining certain organizations. This is fictional, right? I'm not basing this on any specific data, but you can look at where down 10 shows that kind of falling off of a cliff, the dawning of realization that releasing a React package, right, to Vue.js or something to update a version of a dependency takes 2 months. And although I've made this up, I have previously surveyed developers using a Likert scale. How good was your experience? Great, not so good, terrible, etc. And that psychometric scale gives you a really good indicator where you can see people are saying, absolutely, it was the worst thing I ever did, and it causes me pain on a day-to-day. At both types of technological organizational size, whether it's a startup or at an enterprise, this kind of trend is pretty accurate. You'll see that startups are usually more nimble, and it's not really to do with the technology. Ultimately, we have to ask the question, why? Why in 2020, with the cloud native revolution shaking the foundations of every technology-focused company, is that the path to production is more complex and difficult in large companies than small, right? We are all as smart as we were, if not smarter. We're able to solve problems just as fast now, if not faster than we were. Why is it that it is so difficult and so painful within a large-scale enterprise? And so you might think that the answer is obvious, right? It might be that the enterprises are full of different old dinosaur technology and it's all really difficult. The dichotomy between enterprise and startup is not based in technology, it's based in culture. At certain scale, enterprises are typically going to fan out, right? That's how companies typically grow. You'll fan out and you'll create additional hierarchy. So you can do a command and control. Amongst those growing groups within a large organization, you'll get a strata across that. Say, for example, SecOps. People who are very smart about how to keep a business secure will be in high demand, and they'll be asked to work in different parts of the business. They tend to form clumps, right? They gravitate towards each other, just like the cloud hosting people all gravitate towards each other. You don't have 10 different cloud organizations in a single company because it's not very efficient. And you don't want to have 10 different people or 10 different groups all telling you how to do AWS, right? They tend to create silos of knowledge, and these silos become more and more entrenched and more opinionated on how you interact with them. And this really comes with a net impact to overall productivity and interoperability. I like this quote. Martin Fowler, very smart guy, he essentially identifies the concept that runs parallel with businesses, especially their units and groups, which is the more people involved, the harder that process is to flow naturally. And I know that that perhaps sounds like common sense, but you really see this exemplified in the next slide. Here is a very simple kind of Walt Disney-like picture of castles that I've drawn. And this represents a very simple enterprise organization, perhaps 500 people. And already you have these dotted boundaries. These are domain contexts. So each one is a context, a group, a team, a tribe, and they care about something, right? The SecOps team care about keeping things secure. The product engineering team care about producing a beautiful website. And the converged infrastructure team care about whatever their vendors tell them to buy, so VMware or OpenStack, whatever that is. This is a typical example in a large company of who you might have to interact with. If you're an SRE, an application developer, backend engineer, it's not unreasonable to think that all of these teams might want you to talk to them at some point if you're trying to release something. So think of all these teams as gatekeepers. Equally, when we actually visualize the sheer number of moving parts, the philosophy behind improving enterprise interoperability, I think, becomes a bit more apparent, right? You've got this flow. It looks nice on this diagram, but as we all know, it's never really this clear cut. Half of these arrows could be representing emails. Some of these could be Slack chats. Some of these could be Jira tickets. And this is a relatively simple example. Cutting a local release and rolling that out is displayed along with some of the typical processes and the blocks that are effectively gatekeeping them. For example, Docker image scanning, or somebody checking that you've got the right Adobe SDK for gathering analytics, that kind of stuff. What do you think the chances of automating all this are in a single cohesive flow are? 0. I would love to be able to deploy something out into the wild, declaratively from a single YAML file from GitLab in a large-scale enterprise organization, but it's not really possible because it relies on ubiquitous and commonly accessible APIs, which just don't exist, right? Again, talking about a mainframe, if I need to update the mainframe to tell it that the credit card details have been touched, I probably can't do that from a Jenkins HP call, right? I might need to use some other service or some other system, and that system might have an identity provider that I don't have access to. So let's think about that crux of the problem in another example. If we have a physical firewall, like a Palo Alto network firewall that gets installed in a data center, they have an API. You can update firewall rules, but that API doesn't get shipped out of the box with Active Directory, and your company might use Active Directory. So therefore, guess what? You've got a team who has to build Active Directory to wrap the API to run the firewall. This is a very typical trope in enterprise organizations. And what about the team that manages Cassandra, but it will only service requests through email, and the lady that does the email request is on holiday, right? It's so easy to see how this dysfunction is systemic in large-scale organizations. So with the mandate of we want to create a developer experience that feels like a startup, it becomes a lot simpler if we can bucket what the primary considerations are. So inventory of considerations for us when thinking about how do you circumvent problems and navigate this really complex topology to provide a good developer experience. Well, consider the existing ecosystem, right? Going big bang and saying, right, we all have to write a standard OpenAPI 3 API is never going to happen. You will get set on fire and voted out of that company super quick, right? People want to see small experiments that are successful. Be very, very narrow, but go deep, right? Do a POC that shows a full end-to-end integration, but it doesn't span different lines of business. Again, I'm speaking in regards to an enterprise. This applies to medium-sized businesses. Even if you do have 7 or 8 engineers and you own across your group all of the various components, whether that's SecOps, whether you're doing CI/CD and engineering, it's still not practical to go big bang more often than not, purely because of the amount of new work that you're introducing, the amount of instability and mutability of change. Rough edges. Rough edges means to me that not all services and systems within the internal enterprise ecosystem are mature at the same level. You might have that mainframe that has a CRUD API on the front of it, but that CRUD is extremely premature and doesn't support any sort of concurrent operations. And so you get 2 TPS off it, which means that they have to wrap it in another API, or there's a special way to call it. This is actually an extremely common issue. And this idea of rough edges, I think, is quite good visually. Just think about how to get that smooth interface, there is a lot of legwork that needs to be done. And thirdly here, security consensus. Security concerns may overlap, but they're not always the same. The mainframe team, the firewall team, the converged infrastructure team probably care about some of the same things, but they're not all bound in the same business unit. They're not all thinking about the same problems. And therefore, it means that security consensus is extremely rare within large-scale enterprise orgs. And 4, tiers of service. Some services may only want to expose part of their systems. Like with an S3 bucket, you may only want to set part of that folder to public access. It's the same kind of philosophy when you think about internal enterprise systems as well. So therefore, when we thought about how do we circumvent and navigate this landscape, it really came down to there being more a vacuum of what was available. And that vacuum, I'm glad to say, has been really filled by the tremendous constraint-based engine that is Open Policy Agent. So for those of you who have heard of Open Policy Agent and those of you who haven't, I'm going to talk to you about it for a few minutes before we go into the more in-depth detail and examples of how it's being implemented and what the opportunities are here. But when we think about the enterprise infrastructure landscape and the enterprise developer experience landscape at the moment, it is fair to say that many companies outside a few who specialize in technologies such as this, such as Google, Heroku, Sysdig, these other companies that have great DX, most companies are in this same position. And so when you have an open source general purpose engine that unifies policy across the stack, it gets a lot of attention. Open Policy Agent is not an old project, but what it does is pretty groundbreaking in terms of decoupling policy decision-making from policy enforcement. I get really excited about this. And what's funny is that it's such a dry topic, right? But it's exciting because of what it represents. When your software needs to make a policy decision, it queries OPA, which is the abbreviation of Open Policy Agent, and supplies structured data, such as JSON, right? Can I do this? Can I do that? OPA accepts arbitrary structured data as input as well. And what's really interesting is that it's currently an incubating project within the CNCF, so the Cloud Native Computing Foundation. However, it's got a lot of momentum behind it because of some of its capabilities that are rather unique, which I'll go into in a moment. What about the competition? So when you're assessing tooling for constraint-based policy engine, you have to do your due diligence. There are several different cross-cutting technologies available. There are services available, such as IAM by AWS. IAM is fairly complete. However, it's extremely complex to write policy if you're not familiar with it. And there's Casbin, which is a Golang library. You could drop it into your own server and then start building out the components around it. And then the actual types of methodology, such as ABAC or RBAC, right? So an ABAC or an RBAC engine could work really well, but you have to implement that from scratch or find some sort of implementation. So we've gone through all this. Casbin is batteries not included. Casbin is a great library, super robust. It has even Docker images available, but it's not batteries included in the sense that it's not as extensible. It doesn't have the same simple package philosophy as we'll come to look at with OPA. And there's not enough momentum around it to really make us feel confident that it's going to be around in 5 years. Equally, IAM is a great system if we use AWS. A big problem is when you're going cross-cloud, you need to have a policy agent API that can work anywhere. And so therefore, it was excluded fairly early on. And in regards to ABAC and RBAC, not as services, but as approaches to implementation, well, to be fair, Open Policy Agent doesn't yet support things like separation of duty. So you can't have sort of an XOR within OPA, but it does enable a much more simplistic model to work with from a developer point of view. And I'll dig into that a little bit in the next slide. And just to sort of underline this, OPA isn't a silver bullet, but when considering all of these options on the table, it's the most complete solution. And hopefully over the next couple of slides, you'll see the next few features that really set it apart. So, declarative, policy context awareness. OPA has a declarative policy implementation, which is inspired by Datalog, which is an ancient format, and it's called Rego. Rego extends Datalog to support structured documents such as JSON, and when you make a Rego query, the assertions on the data are stored in OPA. These queries can be used to define policies, and they can enumerate instances of data that violate the expected state in that system. And so you'll see here, I've got a very simple Kubernetes package implementation. It's, as you probably picked out, it has Golang that backs it. OPA is in Go. And this Kubernetes package or module that's been built into OPA, comes out of the box, enables you to check with the admitting object whether or not it is allowed to create images that start with huli.com. And you can see that starts with, that's a built-in function. So that starts with is something that someone's built and has been included within that package. Taking this a step further, we talked about Kubernetes, and I think I've mentioned that maybe 2 times in this whole talk, but obviously Kubernetes is incredibly paramount to where this is all going. Having a common container runtime platform that we run almost ubiquitously is super important that OPA were to integrate with that. When you're at an enterprise scale and you're running maybe 50,000 pods, maybe 25,000 workloads, it's really important that you can bring all these technologies into that environment in a seamless way. And so OPA has a first-class integration with Kubernetes. OPA Gatekeeper is a project that builds on top of plain old OPA. And what it does is it creates an open policy agent admission controller. So that admission controller piggybacks off the back of the API server webhooks for mutating admission webhooks and says, hey, there's an object being submitted. Can you send it off to open policy agent, see if it fits the constraint policies? If so, then come back and instantiate that object. It's extensible. It's parameterized policy library. Native Kubernetes CRDs, which is great. So you can build out constraints. It also has CRDs for constraint templates. So as a cluster admin, I can create, X amount of constraint templates as CRDs. Thanks to our first speaker, we know what all this stuff is now. And these CRDs can sit at a cluster level. And then if somebody wants to implement it, they can implement that constraint as a CRD within their namespace. So if somebody wants to do their own version of Docker image checking, they can say, I know there's a constraint template for that. I'm just going to implement a constraint. And therefore, it is a much more simplified version of having to write policy. On top of that, you can share policy within a Git repository. You can apply a GitOps methodology so that the policy is kept in your own local repository just for my project, and things that I care about on top of everything else can be checked. And the inverse of that is that if a developer has no policies, they just push an object into K8s, I can make sure that all of the other constraints that, for example, SecOps and converged infrastructure and cloud engineering care about are being checked as well out of the box. And if that wasn't cool enough, OPA also supports WebAssembly, which is very exciting. So WebAssembly WASM, if you don't know about it, it's a binary instruction format for stack-based virtual machines. It was designed as a portable target for high-level languages like Rust, and it enables deployment from the web client and server applications, and C++ as well, of course. It's really exciting as a component because WASM modules are super low latency because they are built directly in to OPA. So essentially what you could do is from a Vue.js implementation. I'm not a JavaScript guy. I'm sorry. I shamelessly just put this in here, hoping I could express what I was trying to from a great tutorial I saw. Links will be at the end. And what you can see is that a new Vue.js application, they've actually created a policy on boot in JavaScript. And I think that's pretty damn cool. So Open Policy Agent lets us create a new type of Kubernetes self-service experience. As we said, we've looked at the competition. We've found that there are loads of gaps within them. There's no real complete solution, and there's nothing that the CNCF are backing as a horse in this race. So OPA makes us feel pretty good about where it's going, and we can already see plenty of places to use it. So let's take a look at how our first diagram within an enterprise organization might look when you add OPA into the mix. So we've talked about how does OPA work. Well, in Kubernetes, somebody would submit an object via the REST API. So that'd be from your kube control. That hits the API server. The API server has an object submission pending. That goes through admission review. The admission review then queries the policies that are currently loaded, and then the admission response is charted. And then the controllers will then create the pod or the object based on its type. And so I've got a few things here which are kind of interesting to think about, and let's think about where we can take that. So if OPA supports every resource type, and I like making custom resources, OPA can also support custom resources, which means I can have a custom resource with a custom policy and have a completely new language on top of Kubernetes. So let's think about, what does that then enable us to do? Well, it enables you to do bring your own service. If you are armed with a constraint policy, an OPA runtime extension, and a service operator, essentially you can say, hey, I own Cassandra, or I own F5, or I own the mainframe. You can interact with my product from Kubernetes natively. Now, let's dismiss service catalog here for a moment. That was a failed experiment. But you can interact with that service natively through an operator or through some resource that we agree upon in a way where I can make sure that the constraints that I care about are being met. So what's this term, service operator? Well, service operator is a colloquial term for a Kubernetes resource, a custom resource that's provided by a team to talk to their infrastructure. The operator pattern, as we've heard previously, enables an economical use of the interface with that resource, right? So what's really appealing about this is if you've got a mainframe or a database that has some persistent JDBC connection or a thread pool to an F5 load balancer, then your service operator can deal with that. And when you have an incoming request via a tenant service or a tenant application, you can choose what to do with that. So let's think about this in very real terms. So if I work on a firewall team, I might want to create a service operator to provision a firewall that will then write a secret with the provisioning address and have the PEM file embedded inside that secret for the calling application. I might also write back a CRD explaining how that is to be accessed so that the calling application knows that it has to expect a resource to exist. Now, this is a very complex operation, and that's why having a policy would be super useful, so that firstly, I can check the Active Directory user of the service account. I can integrate OPA backwards through DEX. DEX is an IODC, so you have identity providers. Sorry, DEX is an IDP, which is an identity provider, and it implements the IODC protocol, which enables open identity connection. I've just said a lot of acronyms there, so I'm going to try and explain that a little bit slower. You can have a service operator that is fueled by policy. This policy can be used to check you are who you say you are. When I do kube control apply, it can check my service account. It maps my service account back to my user, and OPA can have a module that then integrates either directly with DEX as a service, or it can just use Golang there and then, right? OPA could just say within the OPA pod, I'm going to make a call out to Active Directory, and I'm going to check that this is who they say they are and come back again. You can extend OPA with your own modules, which is really cool. Once that's done, the service operator says, well, it passed the admission phase. Therefore, it is not incumbent upon me as a service operator to have to do this authorization check. We don't want to have multiple stages of authorization check doing the same auth check. It should be done at the API server level when you're first admitting the resource. Why would you ever let a resource into the cluster if it wasn't authenticated to do the thing it's trying to reconcile? Let's think about a second example. If I work as a database operator, I might want to create a user for access to that database. So somebody creates a CRD called, database team user request access object, for example. That gets created. It's passed the policy that the user exists, that they have the right entitlement. From OPA, the package that we build into the OPA binary might go off and check directly, or it might simply annotate the admitted object saying, yes, this is passed, see this reference. Therefore, the service operator, upon seeing the CRD, can say, okay, I can see that OPA is okay with this, and he's given me a reference for the ServiceNow ticket or the escalation group or whatever it might be. So therefore, I can go on and service this request. So I think to a few of you, this kind of factory-style pattern might start to be emerging in your minds as just seeing how we're doing this, because you can then call operators of operators. I'm going to park that there because that is where it gets very academic. Let's talk about it and really think about it in a real life scenario, looking at the diagram we had earlier and thinking about how does this actually make people's lives easier? Okay, well, as a product engineering team, my goal is to deliver things into production as fast as possible in a safe way that adds value to the customers. So in this case, what I'm going to do is I'm going to create a CRD. That CRD might be committed to my Git repository. Using Argo or Flux, that CRD could then be pulled from that repository into the local K8s cluster. However that happens, doesn't matter. At this point, OPA will have a look and say, hey, you're trying to admit something. I can see that I've got two policies here, cloud provisioning policy and business intelligence policy. I'm going to look at the cloud provisioning policy and check if your CRD has the right ADS username on it, for example, or has the right annotation. If that annotation exists, great. I might also check to see whether or not the service account it was created by has the correct level of access, so on and so forth. The example could be extended to however far you want. Secondarily to this, the BI policy module might check within a specialist compiled module if it has the requirements as to the business intelligence. So you'll see that it's really a two-step process, checking policy and then backing that policy by packages that you can build into OPA. You can either build them indirectly or you can call them from the Golang of OPA. And OPA is very extensible in this sense. Once this is done, you can see that we instantly are then able to create or rather hit both these cloud operators because they will be polling and looking for CRDs which match their profile, and we can go on and create these provisioned resources. What's nice about this model as well is that it unifies and it also increases the amount of reusability of policy and decreases the amount of human toil, because believe it or not, a lot of these operations that I'm talking about right now are manual in many, many organizations, and there's a huge time component. And realistically, this is one of the best ways we've seen so far to automate a lot of this process. So with that said, let's have a think about what we've discussed and what does OPA really bring. So Open Policy Agent provides a common vocabulary. I whizzed through it quite quickly, but Rego files being in more or less readable format to the human eye is super useful because it means that an engineer can see the constraints listed, they can test them locally with the OPA test tool, they can simulate a deployment through to production and make sure that they're hitting all of the policies that are required. It also means that SecOps and enterprise security groups across the organization can agree upon a set of standard Rego policies that will be injected in config maps into the kube system space or into the gatekeeper space of a cluster so that they always feel like they're in control. Therefore, they can utilize GitOps, and the SecOps folks can start writing their own Rego policies as config maps, which means that there's a whole new tier of persona operating within the cluster that we've only really seen from an academic point of view so far. It orientates service owners to produce a common interface. So this is the thing where we talked about, do you go out within an organization and say, hey, you've got to do this? It doesn't work like that. If you can create a platform to where people want to bring their own interface, then they will, in small experiments, say, okay, well, we've got some free bandwidth. How much work would it be? Okay, use Kubebuilder. Write your own templater on top of Kubebuilder to produce not only an operator, but perhaps have an operator that also then spits out a couple of Rego policies as well. You could do it a bunch of different ways. And in fact, some of the successful ways to do so have been to start really small. Don't have a service operator, just simply have some constraint logic. If I care about making sure all the images that are in this cluster don't come from Docker IO, and they come from the internal proxy, start with that. What this is really important for is that it creates community. You'll start to see that people are like, okay, well, where do we host this? What repository? How does this work across enterprise Kubernetes clusters? Well, you start to then have a common stack that gets deployed, and you start to move the entire organization in that vector towards cloud native. And lastly, and I think I just hit this point previously to this, it aligns the technology group as a united community. If you can imagine moving to a place where even someone working on the mainframe system sees an opportunity for them to create an interface, and that interface being protected with constraints, they're ticking all the boxes for their leaders, but they're also modernizing the way that that system is accessed. I mentioned the mainframe having maybe one or two TPS. Well, it could be the case that the service operator controls the mainframe API rate. And this is bringing a host of new skills to mainframe engineers. If I'm sat there writing COBOL 24 hours a day, this doesn't force me to stop writing COBOL. It just means that I can also write Golang. I don't have to write Golang. I can write YAML, right? So it's really just changing that company culture and bring a lot of positives towards the future of the organization. Lessons learned. So I don't think it would be appropriate to sort of preach this stuff without talking about the things that are really challenging and the things that are still unknowns. It is far harder to create a new ecosystem than enable interoperability. Trying to force this as cloud native gospel will make enemies very quickly. The best way to pitch this kind of momentous change is to have a kind of a poker table approach of, if you want a seat at the table, this is how we play, this is what you can get out of it, you can really improve your life, rather than to sort of push it down people's throats. And I found the most success is internally is to just talk about the benefits of how you can start to enable people, rather than having a company, an organization or a group fielding 3 people on production support, 3 people on ticketing, and 3 people who are working on trying to triage issues. You can move to a model where you're automating the policy, the constraints through OPA. Rather than reading a JIRA ticket and looking at labels, they can automate that through the constraint policy. And therefore, it means that whether a developer is in a lower environment, say dev environment or production, you know that you're being protected, but also it's enabling them. They're not having to open a ticket for every single environment that they're working within. So likewise, I think that it's super important that you start by demonstrating what the value is here, and you try to look at bringing people in an inclusive way, rather than to create a new ecosystem and saying you can only play if you do it by our rules. It's far more the case that if you show the benefits, that is where people will start to want to get excited and start to interact with you. You need to go full throttle to take off. I think that this is I had a lot of plane metaphors. I mean, the whole passport thing was something that was in my head at one point. But yes, the idea here is that once other teams are building towards your architecture, you're really on what I would call a critical mass. You've got enough mass at the point where it's going to start showing value extremely rapidly. What I've already seen happen are teams sharing Rego policies as config maps through Helm charts, and then they're hosting their own Helm servers. So we have different parts of the organization hosting everything you need to know about interacting with, say, their Kafka server or their Cassandra server or their various APIs in charts. And that's a long way that we've come, in a couple of years, being able to do this. And once you get to that point, it becomes self-sustaining. And lastly, when you enable engineers with automated process and this kind of beautiful DX, they become stallions. It's pretty awesome. Like, being able to deploy to production through an automated system at an enterprise scale is a holy grail, but it's possible, it's doable. I've seen it done, and doing it in small increments is the way to do it, by creating robust, policy-controlled, cloud-native infrastructure. If you're interested in this, I wrote an article on the interoperability of enterprise technology organizations. Please check it out. Happy to answer questions later on. But it's not a solved problem space by any means. We are certainly just getting started. OPA is still incubating. There are other projects that are starting to compete with OPA now as well. It might be the case as well that, I didn't mention that OPA integrates with Envoy proxy natively. It integrates with microservices natively. It might be the case that you build an OPA engine into your existing server. So there's a lot to be said on this, and I think we're only seeing the start of the innovation right now. I hope that was useful. Please reach out. Talk to me about service mesh, serviceless function density, all that stuff. Universal data plane. I'm a big fan of these things. Check me out, and I hope that was interesting.
Thank you, Alex. Thank you. This was super interesting talk. And I think it's really valuable, especially from someone working for a large enterprise company. So straight from the battlefield, I would say. Absolutely. Let's have a look on the let's have a look at the questions. We have so far 3 from GS795. So the first one is, what is your current initiative on hybrid cloud technologies at Amex? Any pain points you can share from a cloud infra perspective?
So from my personal perspective, and just anecdotally, I only speak for myself here, but from my experience, the hybrid cloud strategy isn't so much create a single ubiquitous cloud, right, where you can shuffle data between a service mesh running on-prem and one running in GCP or AWS. It's more about a series of small bets and having a series of failover strategies. So I think that a lot of companies, maybe Amex to some degree, but other companies I've seen as well, are looking at hybrid cloud as a way of reachability, a way of balancing financials so that they have options. There is a severe fear of vendor lock-in, but as we start to elevate our area of concern into container runtimes as opposed to the actual underlying infrastructure, we're seeing a level of maturity in tooling that enables us to deploy anywhere. So just to sort of answer your question again, hybrid cloud is very much becoming a backup strategy. And the idea that you'll run several clouds, they're not all linked together necessarily, but you have the ability to deploy to anyone you want to at any time.
Thank you. Perfect. Second one, how are you measuring and tracking your progress towards your cloud goals within the business?
So I think that's a really interesting question. And I work within enterprise architecture. And again, this is purely from my own point of view, but we still have to show value. And I think that that's a really interesting one. DX it's always going to be debatable how you measure the value of DX. The same with DevRel as a job. Actually, it makes me think about that, because there are people who would argue, oh, well, what's the tangible benefit of giving developers a Heroku-like CLI? That is through building measurability and traceability at every step. And I'll just give you a quick example that hopefully will answer your question. Building things like a CLI out in Golang. You take something like Cobra, you add Jaeger, you add Prometheus, you instrument the entire thing, and then you add a level of Grafana dashboarding where you can trace interesting metrics, right? So for example, if I look at Jenkins and I know, or I look at GitLab and I know it takes 13 minutes to deploy, and I can see an engineer is running that deploy 3 times a day, but of that 13 minutes, 5 minutes is spent trying to get the executor to launch. Whereas if I build a CLI that enables the same behaviors locally, I can measure that difference. And so it is incumbent upon you to do a lot of the legwork, but we back it by telemetry and metrics. It's the only way to be successful, actually. And that becomes a very second nature behavior when you have to go after funding, when you have to be able to show a tangible difference. And just finally, one anecdote as well, is that when you're thinking about something like OPA, you can measure OPA in man hours, or sorry, person hours, to be politically correct here. I mentioned hiring people. It's totally true that you have teams of engineers who will sit there writing a wrapper API so that you don't need to, or you don't have to call Cassandra or something like that directly. You can show the difference, and essentially it cuts that out of the equation, and they can be distributed to do more high value activities. And this all comes from that SRE philosophy of, eliminating toil. And I'm an SRE at heart, so I think that's why I'm pushing that so much.
Thank you, Alex. Last one. Any new projects that you are working on at the moment, like GitOps Kubernetes one?
Yes, so I personally, and this overlaps with some of the stuff that I've done previously and some of the stuff that I'm doing sort of in more of the open source community, and that's looking at how you create almost like one-stop starter clusters. Because the ecosystem in the CSCF now is so crowded, it's often a bit overwhelming to understand where to start, right? You've got database concerns, you've got security. And so a lot of what I try to think about now is how you simplify that experience. And there's some really interesting projects, and there's some interesting companies out, like Pulumi, for example, who are trying to codify this into a very simple experience. And so a lot of what I spend my time on now is how would you, by example, build simple clusters out that people can practically use, almost like Kelsey Hightower once said, and Kubernetes is just reduced to a very simple API like K3s. And I'm almost saying go one step further in that, Linkerd, Istio, all that stuff, you shouldn't have to think about that too much as a developer. What's the next step? So I've got a few projects ticking over in that direction as well.
So we should definitely stay tuned, man. So Absolutely. This is it. This was the last questions we have. Maybe, Terka, we can bring all the speakers on the stage. I just want to thank you a lot, guys. to Alex, to Anton, and to Ondřej. That was really great to have you on board. We are now on the finish line of tonight's meetup. Thank you all, the audience, for joining us tonight. It was a pleasure to have you on board, even online. Thank you, Terka Grill. Thank you, Marek Bartik, and the whole team to bring this meetup live. And thank you, definitely, Revolgy, for powering this great event. Guys, enjoy the Christmas in about a month, in the most calm way, without the crazy rush or that shopping money out there. And as the most important, stay safe these days. We will definitely bring you the next meetup in January 2021. And by the way, as other speakers also said, we are constantly hiring in Revolgy. So have a look at our website, our Twitter, or ping us a message if you will be interested in having a coffee with us, at least the virtual one. And I think we can see you in the meetup after party. We will provide you with a link for the meet. I think that this is the way how can we meet tonight. So it should be in the chat right now. Do we have it? Cool. So it wouldn't be as great as if we can meet in person, have a beer, grab a schnitzel, but at least let's meet virtually and hopefully see you in the physical world ASAP, guys. Thank you, everyone, for joining us, and see you next time.
Thanks for having us.
Yeah, thanks, guys. See you.